And today in our session, we're going to talk about machine learning and data. So we're going to talk about what is data and types of data. So let's begin. We have already understood what is machine learning, supervised learning, unsupervised learning, and reinforcement learning. Let's just take a revision of it again. So we saw that AI, or artificial intelligence, is when we try that machines should be as smart as human beings. Machines should have intelligence as human beings have. And under AI, we have machine learning. So AI would be the concept, would be the science, and machine learning would be the technology. So how do we implement AI is what is machine learning. Machine learning is the tool by which we implement AI. And there are other aspects of AI also, like computer vision, like natural language processing. So we'll be talking about all that also in future. So in here we have machine learning. So let's look at what are the other aspects of machine learning. So machine learning can be done in various ways, but currently two methods are very popular: supervised learning and unsupervised learning, and also reinforcement learning. But more work is getting done in supervised and unsupervised learning, which is already so prevalent around us. Reinforcement learning is also coming up in certain areas like gaming. So to understand supervised learning, in supervised learning model, the algorithm learns on a labeled data set, and that labeled data set has the answer key. So for example, if you have 100 photos, 50 photos are of a cat and 50 photos are of dogs. So all those 100 photos are labeled. We know that this photo belongs to a cat and this photo belongs to a dog. Whereas in unsupervised learning, we have 100 photos, but they are not labeled. We do not know which label, which photograph is of a cat, which photograph is of a dog. As a person, obviously, I can see and look at the photo and identify this is a cat, this is a dog, but there is no label in my data set that tells the computer that this is the picture of a cat or this is the image of a dog. And what are the algorithms that we can run on unsupervised models, unsupervised data, and what are the models we can run on supervised data? Then what is reinforcement learning? Reinforcement learning is an area of machine learning concerned with how intelligent agents ought to take actions in an environment to maximize the notion of cumulative award. So if a game is being played, if the computer is not playing it well, he will be penalized, and if it is playing well, he will be rewarded. So the accumulation of points will be more when there is reward. So the algorithm is structured in such a way that the algorithm takes actions in which more rewards are offered rather than in which more penalties are offered. And that kind of learning. So the computer is learning more and more and going in the direction, the algorithm is gathering more and more information in the direction in which it is getting reward and not going in the direction in which it is getting penalized. So that would be a reinforcement learning concept. Let's look at supervised learning further. So in supervised learning, the algorithm learns on a labeled data set, like I mentioned. So there is a data set and there are labels available. So there is a column. So for example, let's look at our data set. We have some data sets here. So we have these data sets of, say, television, radio, newspaper, and then sales. So this, we are saying that we know how much sales are happening for TV, radio, and newspaper. And we have, for example, we have a bank data set. So we have, in a bank data set, we have age of the subscriber, then job, how he's employed, marital status, education, default, whether he's defaulted or not, what is the account balance he has, whether he has housing loan or not, whether he has personal loan or not, whether he's been part of the current account campaign or not, whether he has been part of any other previous campaign and then subscribed or not. So this subscribe channel would be my Y variable, because I now know that this kind of person, that a person with these features is not subscribing. So this becomes my label. If I have to find out, if I have to predict what kind of people subscribe. So for example, this is a yes. That means this person has subscribed, right? So previously, he has no personal loan. He was part of the current, he's part of the current campaign. He was not part of the previous campaign. His account balance is 502. He has no default. He has secondary education. He has a marital status which is single, and he's a student, but he has subscribed. So people, that means people of these features are subscribing to my bank advertising campaign. So this becomes my labeled data set, right? So in the same way, we have the data and we have the label. So if we have the data about some figures, we know that a figure with 6 sides would be a hexagon, a figure with 4 sides is called a square, a figure with 3 sides is called a triangle. And we put all this labeled data set, the data set along with labels in the model. The model trains itself, and then we provided a new data set, which is the test data set. This is called the training data set, and the new data set is called the test data set. And when we provide it with the features, then it is able to predict whether it is a square or a triangle. And if it is able to predict all the features correctly, that whether a square is a square and a triangle is a triangle, then we say it is 100% accurate. So the model is good. So we measure the accuracy by finding out whether the model has been able to predict properly. How many items that we entered, that we asked for prediction, have been predicted correctly. How do we know? Because we have a test data set that has the predictions already with us. So we are able to do that. Once the model is made and gives us high accuracy, we put it to production and we use it for further prediction that we would want. So this is how it happens. So once I say that this is a data set which has labels. So this is my training data set. I put it in the model learns from it, and then I use it for prediction using the test data set, and then test the accuracy. If the accuracy is as per my requirement, then I put it to production. So this would be supervised learning. Again, to come back to our bank example, if we see, then I have all this data. I have all this data, and this is my Y label. So I want to predict whether a person will say yes to the campaign or not. So what I do, I have how many rows? I have 4,522. I have 4,522 data sets. So plus 4,522 into 0.8. So I'm taking 80% of the data set. So I will take around 3,600 and say 10 or 20 data out of this and make a model. And then I'll use the rest of the 20% of the data to test the model. How will I test? I will give it one row of information. Without this, I will give these features to it, all the X features, and I'll ask to predict whether it is whether that person with that features, who's 37 years old, management, married, tertiary education, all these features, whether he is going to subscribe to. How do I predict whether he will be subscribing to my bank campaign or not? And then I test it with my 20%. I test that model with my 20%. If the accuracy is good, then now I have a model that helps me to predict whether a person is will subscribe to my data set or not, right? In the same way, we have unsupervised. So in unsupervised model, in contrast, we have no labels. We do not know which picture, which image is of a cat or which image is of a dog. And then what we do is we put it through an algorithm. Algorithm learns on its own whether it is a cat or a dog. Actually, it doesn't name it. What it does is it categorizes. It says there are 2 categories of animals. How does it know there are 2 categories of animals? Because of the features that they have, right? Because of the features that they have. So dog would have different features, cat would have different features. So that will, if I provide them the data, it will process and give me outputs like this, right? So this becomes my unsupervised. So unsupervised learning is used a lot for clustering. So for example, you have customer base, right? You have a lot of customers and you want to find out, is there any segmentation in my customer? Then what you do, you give it to an unsupervised model and it is able to segment it under different customer segments. For example, here we have the data set of height and weight. And we do not know whether it is a female or a male. So we have only height and weight. We have only these two columns. Then that information would only be for unsupervised. There is no labeled column. So if I plot this information, then I can see through the plot that there are two segments, two clusters of data points with me. And then I can say, so the computer will tell me two clusters. It will not tell me whether it's a male or a female. It will just tell me that there are two clusters. And then I can interpret that these two clusters might be, two different types of people, right? So if I have this column, which is my Y variable, then I will be able to say that there is a label that a person of this weight and this height is a female, right? So then I will be able to use that as a supervised learning model and use it to make prediction. So for a supervised learning model, I can have a prediction like this, where Y, which is my prediction variable, which is my gender, is equal to beta 0 plus beta 1 x1 plus beta 2 x2. When I say I have to train the model, what exactly I'm doing is I'm finding out the values of beta, right? Because I already have the weight, I already have the height. So what I do, given my data set, I take 80% of my data set and use that part of my data set for training my model. So from that 80% of my data set, given the height and the weight and the gender, I find out that what is the values of beta 1 and beta 2 using my algorithm that we will be studying later on. So using my algorithm, say here it will be a multiple regression algorithm. So using my multiple regression algorithm, I'm able to find out the values of beta and then keep those beta values along with x1. So I put in the value of x1. So now after I've made the model, you can ask me that using this 20%, I can test my model, and you can ask me that a person with weight 82 and height 6.2, what is the probability that that person will be male or female? And this model will give us the probability whether the person will be male or female. And given the higher probability that the person will be a male, I will say that the model is saying it will be a male. So this becomes my supervised learning. So in supervised learning, we divide into training and test stage. In unsupervised also, we can divide it into training and test and see how my patterns, how my segments are coming along. Now, at this stage, I also wanted to talk about dimensions. So here we have two dimensions. So we are able to plot it with height and weight. So in my data set, if it's a structured data, then this kind of information I call rows and columns. So weight is my column, height is my column, and gender is my column. These are also called variables. So either they are called variables or columns, and they are also called dimensions, right? Why are there so many names for the same thing? Because we know that data science is a field in which knowledge is coming from variety of fields. For example, it's coming from computer science, it's coming from statistics, it's coming from business, and it's coming from data, right? So all these, and mathematics, of course. So all these contexts had used different terms for it. So a variable would be coming from, say, statistics. A dimension would be coming from a computer science, right? So this data is having three variables or three dimensions. Here I'm able to plot two dimensions, weight and height, and this model has two dimensions. I can also have a model which has more than two dimensions. Now, as a human being, I'm able to only visualize a two-dimension data set, or maybe a three-dimension data set. Beyond three dimensions, I'm not able to visualize it. I'm not able to comprehend it, because as a human being, I have my restrictions. I have my my capabilities are limited. But the mathematical equations can have as many dimensions as it wants. And that is the beauty of machine learning, that we are able to deal with a lot of dimensions. So we saw in our data set here that there are more than one dimension. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dimensions, and then we have the y variable. So in this kind of data set, we will have an equation which will have y0 is equal to beta 0 plus beta 1 x1 going up to beta 10 x10. So it will have 10 dimensions. We will not be able to plot all 10 dimensions in in one visualization. We'll have to choose 1 or 2 dimensions, 3 dimensions from there and then plot, right? So like we discussed machine learning, supervised and unsupervised learning. So what are the kind of applications do these supervised and unsupervised learning models have? So supervised learning models would do classification and regression. What is classification? In classification, my y variable is yes or no, right? So for example, in our banking data set, my y variable is yes or no. So when I can classify all this data into 2 sectors, into 2 classes, either yes or no. When my y variable is a number, here, for example, sales. So I'm saying if I spend so many $1,000 on my advertisement in television, so many $1,000 as my advertisement on radio, so many $1,000 as my advertisement in newspaper, then my sales increases by this amount. And so which is having the most impact, whether it is TV that is leading to the higher sale, whether it is radio that is leading to higher sales, or whether it's newspaper that is leading to higher sales, I can make a model to predict, right? So for each unit of $1,000 spent on TV, what is the impact on sales? So I can make that kind of prediction model. Here my y variable is a number. It's not yes or no. So this becomes my regression problem. So like we have done here, we will run a regression algorithm to understand this better. So whenever there is a regression, problem, we use supervised regression modeling, and we can do forecasting, we can do prediction, we can do process optimization, and we can find out new insights from the data. Like we said, how much a unit increase, a $1,000 increase. Here the unit is in $1,000. So it could be in lakh dollars, it could be $1 million, it could be $1,000, whatever the unit is there in your data set. So here we are saying that for $1,000 increase in $1,000, which is 1 unit increase in our TV advertisement spend, what is the impact on the sales of the product, right? So that would be my regression. When we are doing, we can also do classification algorithms under supervised learning. So it can be fraud detection. It can be image recognition, like we said, whether it's a cat or a dog, provided we have images that are labeled as cat and dog. Then we can have customer retention, which says whether the customer will be retained or not, right? Whether the customer will be loyal to us or not, whether he will be with us in the next quarter, whether he will purchase more products from us or not. And diagnostic also. In diagnostic, there's a lot of application of supervised learning algorithms for classification in diagnostic, in medicine, in medical applications. Here, there's so many applications, whether a drug is effective or not, whether drug A should be given to a patient or drug B should be given to a patient, whether the patient's cancer is malignant or not. So, wherever there is a class to which the data can belong, it comes under classification. And in classification, it's not just 2 classes. It could be more than 2 classes also. Right? Here we can also talk about big data. We've already discussed this once. Big data is any data which has variety, velocity, veracity, and value. These are only the 4 V's. There are other V's also, but these V's are basic V's to define. So variety means that they can be structured or unstructured or semi-structured. What do I mean by structured? I mean that a data set like this, in which there is rows and columns, is structured, and a data set like a video file or a text file or an email, all these are unstructured. So then how do we process that? We convert the unstructured or the content of the email into structured data. There are techniques to do that, and then we use it in our algorithms. Then what is velocity? How fast is data traveling or being processed? The speed of data generation, the streaming, the operations. So for example, you have credit cards, so Visa card and MasterCard. So people all over the world are using it. So at the speed at which the data is coming to the server of MasterCard or Visa card, that would be the velocity. Or that, millions of people are watching Netflix. So which movie are they watching? All that is getting to the server of Netflix, right? People are uploading photographs on Facebook. People are doing shopping on Amazon. So all the data that is coming to the Amazon or the Facebook servers, all that is the velocity. How quickly, how fast the data is coming. Then veracity. Is the data reliable? Is it trustworthy? Can I verify? Is there an audit trail? Can I validate the data? Then it has veracity and value. For a particular business questions, what kind of data do I need? Is the data valuable to me, or I'm creating rubbish and saving rubbish and storing rubbish data that I cannot find out any meaning out of it? So is the data useful? So if the data has all these 4 factors, then we call it a big data. Okay, let's now come to what exactly data is. So we'll do it in the next session.